This is Mr. Mumba presenting the physics lesson. Today's video will look at work, energy, and power. Okay, so we have been given this question which is saying figure 4.1 shows a ball just before sliding down the slope. So as you can see, we have got this ball which has got a mass of 0.8. So the first thing when you're solving physics question, you have to generate what we call the data or data. How to get it? So now, when you are dealing with this one, first of all, you look for mass, you look for gravity, and then you are going to look for height. So when you come up with this data, it will be easy for you to solve the question. How are you? You have to generate what we call data. So the first thing here, you look at the mass of the ball, which is how many? It's how many? It's 0.8 or 800 altogether, 800 grams. And then the gravitational strength, you can either use this one 9.8 or 10 Newton altogether. So now when you come up with this data, you look for the height. The height where this bulb is, it is how many? It is 10, eh? 10 meters. So now, away from that, okay, so the first question is saying what is the potential energy of the ball at point A? So if you don't know what to do, you don't know how to generate the data, it will be a challenge for you to calculate. So we know that the formula, its potential energy is equal to mgh, where m is the mass, hey? G is the gravitational strength, and then h is the height. The height from here up to here, altogether. So now from there, we come up with what is called the data. We generate the data. So when you are solving, you should always generate the data. The first thing you say, potential energy is the one which we are looking for. You put a P and a question mark. And then gravity, we have got how many gravity?
10 Newton per kg.
We have got 10 Newton
per kg.
Per kg. Or you can say it is 9.8 if you have not rounded it off. Is it clear? And then we have got height. What is our height here?
10 meters.
It's 10 meters. Are we together? So now we substitute these things in our formula, which is potential energy is equal to mgh. So potential energy, what is our mass? According to our data,
0.8 kg.
We have got 0.8 kg. Or if you want, you can say 800 grams altogether. Which one is bigger between 0.8 and 800 grams? Which one is big and which one is small?
It's just the same.
It's just the same, right?
Yes.
But you have just converted them.
Yes.
So now what you do, you're going to say times the gravitational strength.
10 Newton
You
per
can say
kg.
10 Newton, or you can put 9.8. There is no problem, right? And then times what is our height?
10 meters.
Our height is a 10 meter. 10 meter. So now, on your calculator, I want you to punch
80
0. This one. What is the answer?
80 kg. 80 Newton.
80
Newton.
Newton. Now,
Yes.
for energy
It's measured in joules.
so it
80
is
joules.
80 what? Joules.
It's 80.
Okay, so that was the solution for question A. So now we are going. Okay, so now we are going to find the solution for B. So what is the kinetic energy of the ball as it reach point A? B. Meaning that the ball is here on point A. Now it is rolling down the slope. Is it clear? Now we want to calculate here when it reach on point A, B. Meaning from A to B, the formula which we are going to use is kinetic energy is equal to half mv squared altogether, where K is our kinetic energy, is the one which we are looking for. Are we together? So now half, meaning that they have the okay, so when you're solving this question, you come up with the data. Before you solve, group your data here, or data, you're going to say kinetic energy is the one we are looking for. Altogether, it is the one we are looking for. And then our mass, what is our mass? It's 800 grams. What is our velocity?
10 meters per second.
Velocity is 10 meters per second squared. Altogether. So now we substitute in the formula. We substitute. We are going to say kinetic energy is equal to half. Where there is m, we put what?
Mass.
We put mass. Hey, mass. What is our mass?
0.8.
0.8 kg. Is it clear? Kg. And then where the v is, we put what?
10 squared.
We put 10 meters per second squared. So now when you punch it on a calculator, what is the answer? Okay, so when you calculate, you say 1 times 0.8 times 10 squared. Our answer was 8. Okay, so after calculating, we said 1 times 0.8 times 10, the answer was 8. So 8 divided by 2, what is the answer? It's 40. So energy is measured in what? Joules. Now solve this one, which is saying state the role of conservation of energy. What does the role of conservation state? Who can you tell me? Yes.
The law of conservation of energy states that energy cannot be created nor destroyed, but can be transferred from one form to another. That's all.
Yes, very good. Who else has got a different answer? Yes, Fales? The same answer? Are you? The same answer. So it means that you have got the same brain. Thank you very much. Okay, so the role of energy conservation states that energy cannot be created nor destroyed, but it can be converted from one form to another. Altogether. So this one, we have solved it, right? Okay, so let us look at the last part, which is the definition of terms under the work, energy, and the power. So the one which we have, we've got work. So now, what is work? What is work? Yes, Fales? Work is the ability to do something. That is according to her answer. Yes, I saw the hand. The same answer. Okay, Max?
Work. Work, I can say it is the product of force times the distance moved in the direction of force.
Okay. Work is
the product of force. And the distance. The distance moved.
The distance moved
in the direction of force.
In the direction
of force.
Direction of force. If you want, you can say displacement or direction. There's no problem, right? Direction of force. Okay, so this one we are done. Now let us look at energy. What is energy? Yes, Judith? Okay, energy is the ability to do work. So energy is the ability to do work. Energy is measured in what? Joules. All together. It is measured in joules, which is denoted by capital letter J or small letter J. The last part, what is power? Okay, power is the rate at which
Work is done.
work is
Done.
Okay, guys, thank you very much for watching. You can drop your comment, you drop your questions so that we solve.